Okay, for here we're going to look at example 3. They told us that the diaphragm of a loudspeaker moves back and forth in a simple harmonic motion to create sound, as in figure 10.11 shows. The frequency is 10 kilohertz and the amplitude is 0.20 meters. They want to know what the max speed of the diaphragm is and where the motion is when this max speed occurs. Alright, so they give us the frequency is 1 kilohertz, but the standard unit for frequency is hertz, so we have to convert the 1 kilohertz to hertz. Now this frequency means that the pattern repeats 1,000 times per second. So the speaker stretches outward, then back, inward, then back to its original pattern, and it does that every 1,000 times per second. They also give us the amplitude, but just like the frequency, we have to have that in standard units, which means we have to convert it into meters, which is 0.002 meters. That's the maximum it goes beyond, and that's the maximum it goes out and in past its equilibrium point. They want us to find the V, so we can. I know that there's a relationship between frequency and period. I know that the period is equal to the reciprocal of the frequency, so that means it takes 0.001 seconds for the period to repeat. I can use my equation sheet, or I can use kind of like the logic. I know that the frequency or the angular velocity has to be in radians per second, and I know that 2 pi, which is what 1 radian is, divided by the period is equal to the radians per second. So I can use that same formula to calculate that my angular velocity or my frequency velocity, or my angular frequency, is 6,283.19 radians per second. And that's imagining if we had seen that sinusoidal graph. Using that, I can use, just like V equals angular velocity times radius, the velocity max of an oscillating object is equal to the angular frequency times the amplitude. So we plug that in and we find out that the max velocity is 1.256 meters per second, or 1.3 meters per second. And this, for part B, they asked us where it's going to occur. Now, at the furthest point away from the equilibrium, the velocity is going to be 0. It's the moment when it starts bouncing back, and the furthest point to the left of it, it's also going to be 0. So this maximum velocity occurs at the equilibrium point, which is true for all, where the kinetic energy is at its greatest. And that's pretty much it for that one.